this video, we are going to practice drawing the electron configurations for some of the larger atoms on the periodic table. The electron configurations for atoms with a lot of electrons, we follow the same rules that we use for writing electron configurations for atoms with very few electrons. The only differences, or the only thing we need to keep in mind, is the order that the electrons are going to fill the orbitals, or the order with which the orbitals are going to be filled. The Aufbau principle tells us that the electrons are going to go into the lowest energy orbital first. So let's take a look at this. We know that the first shell and the 1s orbital, that's the lowest energy orbital that there is. Okay, so electrons will always start filling the 1s. So here we have low energy, and then up at the top we have higher energy. After the electrons have filled the 1s, then the electrons will fill up the 2s. So they'll go into the second shell and fill up the 2s, and then they'll fill up the three 2p orbitals. Then we'll go to the third shell. The electrons will fill up the 3s. Then they'll fill up the three 3p orbitals. Then we would expect them, of course, the third shell has d orbitals. We would expect that the 3d orbitals, and there are 5d orbitals in the third shell. We would expect those orbitals to be filled next. But this is where it gets a little trickier. The n equals 4 shell contains s, p, d, and f orbitals. And once we get further from the nucleus to the fourth shell, the fifth shell, the sixth shell, the difference in energies between these orbitals gets smaller and smaller. And it turns out that according to the quantum mechanical model, that the 4s orbital is lower energy than the 3d. So the electrons will first fill the 1s, the 2s, the 2p orbitals, the 3s, the 3p orbitals, and then they'll fill the 4s before going to the 3d. So it gets a little bit cloudy as to what order the electrons will fill, or what order the orbitals will be filled. Now, there's a few tricks to knowing this order. And what I like to use is our periodic table. If we follow the periodic table, it can tell us the order that the orbitals are going to fill. So here's our periodic table. We've broken it apart. Here's our first two groups. Here's the transition elements here. Here's the most of our non-metals over here. And then we have our lanthanides and actinides down here. We divide it into groups like this, and we call these first two groups the S block. Okay? What that means is that atoms in the first two groups are having their s orbitals filled. Okay? For example, here the 1s orbital is being filled. Here the 2s orbital is being filled. Here the 3s, the 4s, the 5s, etc., etc. So the period number essentially corresponds to the n number, or the shell that's being filled. Over here, let's call this the p block. Over here, the p orbitals are being filled. Again, there are 3 p orbitals. Each one can hold each one can hold 2 electrons. So we can fit 6 electrons into each of the 3 p orbitals. So we have 1, 2, 3, 4, 5, 6 groups here. So atoms over here are having their the 2p orbitals being filled. Here the 3p orbitals are being filled. The 4p, 5p, 6p, etc., etc. Okay, all the way to the noble gases, which have full p orbitals. Sometimes you hear that called a full octet. We'll talk about that later. The transition elements, here we call this the D block. Atoms that are in this block are having their d orbitals filled. The only difference here, though, is that atoms here are not filling the 4d. Atoms in this period are having the 3d. So this is the shell being filled is equal to the period minus 1. So this is the fourth period, so this would be the 3d. This one, the 4d is being filled, the 5d, etc., etc. And then here, the lanthanides and actinides, elements down here are having their f orbitals filled. So they have enough electrons that they're being having to put them into f orbitals. The shell that's being filled here is the period number minus 2. So remember that the lanthanides and actinides fit in right in here. And so here, we're filling up the 6s, 1 and 2, and then we begin to fill up the 5d, and then we drop down and begin to fill up not the 5d, but the 4f. And here we're filling up the 5f. So again, just to kind of reiterate that, and then we'll work a couple of examples. We begin filling the 1s, then we go to the 2s, then we jump over here to the 2p. We begin putting electrons in the 3s, then we begin filling the 3p, then we drop to the 4s. When the 4s is full, we begin filling the 3d orbitals. Remember, there are 5 3d orbitals, so we can fit 10 in there. If the 3d orbitals become filled, then we begin filling the 4p. After that, we drop down and begin filling the 5s. After that is full, we go to the 4d, the 5p, and we drop down and begin filling the 6s. And right here, it gets a little tricky, but we put 1 electron in the 5d, and then we drop down here and fill up the 4f. If the 4f gets filled, if we have enough electrons to fill up the 4f, then we jump back up here and continue filling the 5d until the 5d is full. Then we go over to the 6p. When the 6p is full, drop to the 7f, excuse me, the 7s. We put 1 electron here in the 6d, and then we drop down to the 5f. So the elements down here, the actinides, are filling up the 5f orbitals, and then they go up to 6d and finally 7p. Again, we don't have any atoms larger than that have more than 7p orbitals that are being filled, at least in the ground state. So let's practice a few of these, but again, be sure that you're familiar with the order that the orbitals will fill in these atoms that have a significant number of electrons. So let's practice writing the electron configuration for the following 3 elements: iron, barium, and tungsten. Now, we're not going to write the arrow notation for these, just the standard electron configuration. So let's start with iron. First, we see that iron has 26 protons, so neutral iron has 26 electrons. So according to the rules that we discussed, we're going to, of course, begin filling the 1s. We're going to write 1s2. After that, we'll begin to fill the 2s, so 2s2. After the 2s, we go over and start filling the 2p. That can hold 6, so we have 2p6. After the 2p, we're going to drop down and start filling the 3s orbital. So we have 3s2. Then we go across to 3p, and we can fit 6 electrons in our p orbitals, so 3p6. After 3p6, we don't go to 3d, we drop down and fill the 4s, so 4s2. After the 4s, we start filling here, now we're getting into the d block. This is n minus 1, so this would be the 3d orbitals that we're beginning to fill. We'd fill 3d 1, 2, 3, 4, 5, 6. So iron would have 3d6. So this would be the electron configuration for a neutral iron atom. Let's practice barium. Okay. So for barium, again, we're going to start with 1s2. After that, we drop down and fill 2s2. After that, 2s2, we go over and start filling the 2p, 2p6. Then we drop down and begin filling the 3s, 3s2. After 3s, then we come over and fill up the 3p orbitals, 3p6. After 3p6, we come over and fill the 4s2, or fill up 4s with 2 electrons. After 4s, now we enter the d block, and so we're filling up the 3d. We can fit a total of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons into the d orbitals, since there are 5 d orbitals. So 3d10. Now we go back to 4p, 4p6. After 4p6, we drop down 5s, 5s2. After 5s2, now we begin 4d, 4d10. After 4d10, it comes 5p6. After 5p6, now we drop back down to drop to the 6th shell and fill up the s orbital, 6s1, 6s2. So barium is right here, so barium would have 6s2. So this would be the complete electron configuration for a neutral barium atom. Now, let's try one last one. Let's write the electron configuration for tungsten. Okay. Tungsten is right down here, number 74. So let's start off. Again, our Aufbau principle tells us we're going to start filling the lowest shell and the lowest orbital in that shell. So it's going to be 1s2, then 2s2, 2p6, 3s2, 3p6. After 3p6, now 4s2. Then we go and fill up the 3d10. After 3d10, 4p6. Then we drop down, start a new shell, the 5s2 orbital. And then we go from 5s2, we're starting here with the 4d10. After 4d10, then we fill up the 5p6. After filling the p orbitals, 5p6, we drop down here and start filling the 6s. We're going to fill up 6s2. Now here's where we have to be very careful. After 6s2, we go from 56 to 57. We're in the d block. So this is going to be 5d1. Okay, so 5d1. Now after 57, look at the numbers. We have to drop down here to 58. This is the F block. So the atoms here are filling the 4F orbitals. So we're going to begin filling the 4F. We have 4F 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Of course, there are 7 F orbitals. Each one can hold 2. So we're going to fill up the F orbitals for F14. Now, after 71, we have to go back up here to 72. Now we're back in that 5D block, so we're going to fill up the 5D 1, 2, 3. So we're going to add 3 more electrons into that 5D orbital. So this would be the electron configuration for tungsten. One last thing though, the 5D1 that we have here and the 5D3, we want to combine those. So we write just 5D4. So it would look like this. Again, everything else is the same. 4F14 5D4. And it doesn't matter if you write the 5D4 before the 4F or after, but we do want to combine the 5D1 and the 5D3. So practice some more of these, writing these electron configurations. We want to be very good at that. Particularly practice some of the larger elements, so those with F orbitals. So practice as many as you can, and good luck.